Now let me introduce Papai Attila. He's a lead engineer at Wise. He's worked for the Western Europe and North America expansion teams, ensuring the smooth performance of Wise's products in these regions. The title of his talk is Moving Fast, the Wise Way to Deliver 200 plus releases a day. Put your hands together for Mr. Papai Attila.
Thank you. All right, hey everybody. I hope you can hear me okay. And yeah, let's kick this off. So, the title is Moving Fast the Wise Way. I'm going to talk about some of the practices and learnings that we did basically at Wise, which allows us to go fast. I'm going to talk about why this is important and how we actually do it. But before that, just a bit about me. So yes, I'm Attila. The reason why I'm speaking about this topic is because I've been working at Wise for more than 5 years now, and I had my share of actually working with these projects and seeing these practices work in live and in production. But that's about it. What is Wise? Again, this is an engineering-focused talk, but I figure it's important to talk about Wise, what we are doing, just so if somebody's not familiar with the company, you have a bit of context. So Wise is essentially the best way to move money around the world. It was founded by two Estonian people back in 2011 they were fed up with the way bankings handled international money transfer, so they decided to fix it. And fast forward to a bit more than 10 years. Now we are a global player. We are providing the best way to handle this thing. And one good indicator of the impact and the scale that we are operating with is that currently we are handling 4% of the world's personal international money movement needs. Again, this is very amazing. Again, 10 years ago we were nowhere, and now we are doing at this scale. But this is also a good indicator that we still have a lot to achieve. So that's it, and let's focus now on moving fast and on engineering. Just to give you a bit of context, like why we have some things to say about this topic. So at Wise currently we have around 750 services running live in production. This is both backend APIs, backend services, and frontend services. For this, we have 700 engineers working in total, and just like our product, our team is international as well, so we have teams located in Europe, in Asia, and in North America. Also, we have around 100 product teams, which means that on average, each team has around 7 members. So if you're a fan of the, I think AWS coined this term, the 2 pizza size teams, we're actually abiding by it. Pretty nice. And there's no surprises here. So we are doing more than 200 releases. So if you do the very complicated math, on average, each team is releasing a bit more than 2 times a day. Why am I talking about this? Why is this actually interesting? It's clear that I'm excited about this topic, but why should you? Why should you care whether you're going fast or not? I figured it would be good to review, let's say, 3 aspects why you could consider doing something like this. And let's start with the first one. Before we do that, what's actually a release? So in my vocabulary, a release is a new feature, configuration change, bug fix, which previously was on your computer, and now it's in production, available for customers to use. The first one is impact. And what impact am I talking about? Well, of course, we are talking about customer impact. The reason why you have a startup, an organization, a product, is because you want to fix a customer problem. Somebody has a problem, and you want to make their lives better by providing your solution. And really, when it comes to this, is like customers have a problem. You have multiple ways to approach like what you actually want to fix there. And the first natural thing that you can do is go to the customers and say like, hey, like, what do you actually want us to do? And they're probably going to describe something that is perfect, has all the features that they need, and they're going to tell you that they want it now because they have a burning problem. But the thing is, you cannot do something perfect right now, right? Because a perfect solution requires a bunch of things. You need to do customer interviews. You need to know all the requirements for the solution. You need to put a bunch of work in it, which cannot be done fast. So what's the next best thing that you can actually do? Well, it turns out as you dig a bit deeper, you're going to realize that it's not the perfect solutions which our customers are after. It's the solutions that improves just a tiny bit in their current situation. So if you can do that over and over and over again in an iterative fashion, you can actually have impact much sooner. And I want to give you an example. I heard this on Y Combinator podcast by Michael Siebel, so I want to give credit. But I think this demonstrates the really good idea, like the really important thing, why this is actually necessary. And if you're not familiar, everything that I talked about so far is really the MVP mindset, this minimum viable product, where you're basically putting out something that you're a bit ashamed, but still improves the situation. So let's imagine that you're a person. I think it's quite easy. Everything is nice and happy, but unfortunately, your hair is on fire. It's like, not good. Your hair is on fire, that's the customer problem. So what would be the perfect solution here? Well, I would imagine some of you might be thinking about a bucket of water or a fire extinguisher, something along the lines of something liquid. Well, here I am doing this iterative MVP approach, and what I can offer you is a brick. It's like, not really what I was looking for, but still, what can you do with a brick? Can you put out a fire? Well, I don't know, at least I can try. When my hair is on fire, I need to do something. So you can grab this brick and you can, I don't know, rub it against your face, push your head with it, and maybe this will help you just a tiny bit with your current situation. And really the lesson here is that it's better to have a brick when your hair is on fire than not to have a brick. And this is really what the MVP mindset that you should be following when we are talking about small iterative approaches. So the next one, when it comes to why it's important to move fast and have releases more frequently, this is also relevant to the MVP methodology, is that next to these incremental improvements that you're introducing to your customers' lives, you also have a chance to learn about the customers. And what you really want to know, what you really want to achieve is you want to learn quickly and effectively and reassess the situation. Because there are really like two ways that you can do that. It's the story of every failing startup, is that you have an idea in your head, you have no customers, of course, but you know everything about the problem, or at least you think. And you start creating this perfect solution. And you don't want to release this to customers because at the end of the day, like it's a bit bad, rough around the edges. You don't want to scare off the people. So what you do? Well, what you do is that you start working in an isolated fashion. I know you work for months on the perfect solution in the hopes that once you release something perfect, customers will come, which in theory might work, but you don't really know the customers. You have no idea what they really want. You have a bunch of assumptions that you're working with, and this can actually backfire quite well. Instead, with the MVP approaches, when you're doing this very small iterative releases, you actually get to learn a ton about the customers. Is this how they interact with the product, the way you anticipated? If yes, great. If no, no problem. You're doing small releases, so it's very easy and cheap to correct the way that you're going. And I thought, because the brick example was so nice to see, we could do like another figure. So on the right, you can see an example of the company which does the former which I mentioned. Develop features in an isolated manner, and eventually releasing something like this, working with a bunch of assumptions for a long time. And when you finally get to the point where you think you created the perfect solution, and you release, and what you really want to hit is that X, which symbolizes the perfect solution, what you're really gonna get is something like this. It's like, great, you release something. I mean, the situation is better than it was before, but it's like not really the perfect solution. So what do? Well, you can blame the stars and you can go back to the drawing boards again, apply the same mentality and try again, and again, miss the mark. And the problem is that since you're not releasing frequently, you don't have a chance to learn about this whole thing, and hopefully by the end of it, and because I was tired of drawing arrows, you actually get to the perfect solution. Whereas with this one, this is the iterative approach. When you release, and you learn something. You're releasing frequently, so you can learn much faster. So what happens? All right, We release something, it helps with the situation, it's not perfect, so let's improve on this. All right, we are getting closer. It's still not the perfect solution. Let's fix, try again. It's a tiny bit different now, and eventually we'll get to this point. And really what you should notice the differences between the two is obviously the perfect solution is a straight line. But we have established that you cannot do a straight line because you don't know your customers. You think you do, but you don't. With the first one, you're investing a tons of resources, whereas with the second one, it's much more cheaper, so it makes sense to go like this. And the third one is really, so reduce risks. So if you ever worked at a company where you have this strict deployment or release schedules, where you do like bi-weekly releases or monthly releases, you know that even if the deployment itself will go out in like 20 minutes, the real work starts after, because something always breaks. Because when you're doing with this type of schedule, like a lot of changes actually stack up. And when you go live in production, what you will notice that out of the, 50 changes that you have in master, which was packaged into the one executable, something is faulty. And when that happens, like everybody's stressed. It's like, okay, this is the time when we need to do the release. We have a problem. What are we going to do? Well, what you're going to do probably is you're going to be panic mode, fixing everything else and try to address the problems. But really, the point that I'm trying to make here, that this is really a stressful event for everybody. And when you're doing bi-weekly releases, you're definitely not going fast. So what's the opposite? Well, the opposite is that you try to do frequent releases, where you don't even have these dedicated events for releases. It's like releases are every business as usual, essentially. And when you go fast, it's impossible to release something big, because when you release something big, it's really difficult to debug where the actual problem lies. When you release like in an incremental, small fashion, it's really easy to understand, like, okay, I released this one, there is one change in my deployment, something went wrong, probably something is wrong in my changes. So it's really easy to roll back, fix your things, and try again later. So I talked about the why, which is why it makes sense to do these frequent releases, but if that's the case and everything is so nice and easy, like, why doesn't everybody do it? And the answer, just like with most things in life, is a bit more complicated. So I figured I could do a bit of comparison with how traditional companies are doing certain type of things and how WISE actually addressed some of the problems that we have. So the first one, where you can actually look for solutions to optimize when it comes to releases, is the organization structure. So if you ever worked with a big and traditional, big enterprise, like a big company, you know that you have this decision-making at the top. You have this top-down hierarchy, and really the people who are making decisions about where the company is going are the people at the top. And actually, it makes sense. At the end of the day, they have the accountability to do so. If the company is not performing the way it should be, they're going to be the ones who face the consequences. So what's the problem with this? Well, the problem with this one is that the people who are making product changes, or product decisions rather, are the people who are furthest away from the customer. Why is this a problem? Because today, one of the big advantage that you can do is go very fast, have multiple releases, and learn quickly. And to that, you need to do experiment and fail fast. But since the leadership doesn't really understand the customer, the people who understand the customers are the ones who are building the product and they're closest to them, what they need to do is they need to explain again and again to more and more leadership, like why this change is required, why at the end of the day this is probably going to be something good for the customers. And when you have this constant back and forth and approval processes and whatnot, this is everything but not fast. And last but not least, even if you manage to get something approved, you still have this problem with strong code ownership. And what this essentially means is that in many companies, you have this structure where only the teams who actually own the services are the ones who are permitted to make changes. So if you're team A and you want to create this great service, you're really depending on this other team so they can actually commit. So you're not blocked with the release. Because once they are not sold in the idea, then you rely on them, wait forever, and that's really the opposite of going fast. All right. So how does Wise do it? Well, what we have is empowered teams. So instead of this top-down, very hierarchical structure, what we are doing is sort of flipping everything on its sides. And instead of having people at the top, like a senior and an executive team, making these product decisions, what we are doing is we are empowering our product teams to make their own decisions. How do we do that? Well, as I mentioned, that we have around 100 teams within Wise. These product teams all focus on a certain aspect of the product and trying to make them better. How do they make them better? Well, you have KPIs assigned to each team. And you know that these KPIs eventually either will make the customer experience better or help drive Wise grow faster. And when you have a structure like this, really, this enables you to go and experiment and fail fast, because now the product teams don't need to explain that or don't need to do continuous explanation why a certain idea is good or why not. The only people really that they need to convince is themselves, because we have this around on average 7 people size teams, and they have all the power to do whatever they want within their domain. Nobody to explain to yourself. At Wise, we don't have a senior leadership who tells you what to and what not to build. It's up to the teams. And obviously, a structure like this requires a high level of trust, but this is one of the changes that possibly someone needs to do. And last but not least, I mentioned about this strong code ownership, which these traditional bigger companies have, where in Wise, what we have is this weak code ownership. What does it mean? Well, it basically means that whenever you want to make a change which spans across all products, it's very likely that you will need to work with some other team. And instead of getting blocked because that team doesn't really want to do that certain change or not right now, what we are doing is every team at Wise is able to check out and contribute to other people's services. And really the only dependency that you have at the other team is that you need their approval once you have a PR. But that's it. You can do your own code change, and really a review is much less of an investment than the actual implementation that the other team would need to do. All right, so you say, cool, we did the organizational change, are we fast now? And the answer is like, it depends, really depends on the size of the organization that you're working with, but if you have many and many engineers, the answer is most likely no. Why? Well, I'm not really going to go into this because I would imagine that there's at least a dozen talk about right now at Conf, which are talking about why monoliths are not the answer. But at Wise, what we have noticed, and what many companies notice at the same time, is that you're going to hit limits with the monoliths about a certain number of engineers. What are these limits? Well, you have these long development cycles where you're basically working on the same code base. Everybody is working on the same code file. You have merge conflicts, but even if you don't have merge conflicts, you're going to basically wait for long CI times. And I think I said the wait word like 3 times already, so that's definitely not fast. Then you have this thing called blast radius, which is essentially the chance that somebody else, who's not even related to your team, does a change in the other side of the application, which eventually blows up in your face. And then there's a dependency. If it blows up your face, now the master is broken, then you need to do a revert, and you need to wait until it's fixed, and then you can deploy again. Again, not fast. And last but not least, when you have multiple people, multiple engineers working on the same code base, you'll essentially have just a big complexity. Even if you're like the best engineer ever, the code base eventually will get very big, very complex, very difficult to manage. And obviously, when you have trouble understanding the code base, you're not going to go fast. So what's the answer? Well, of course, the answer is microservices. Not really. So microservices when you have multiple people or multiple engineers working at your company. And really, I just want to show off the journey that at Wise we did with this adoption. So successful startups always start with a monolith. And as they grow, they decompose it. But you shouldn't start with a decomposed stage just because you might eventually end up with a microservice architecture. You really need to understand when you're making this decision. So again, 2011, Wise just started. It's 1 or 2 people. It makes sense to start with a monolith because you want to go fast. So in 2014, we have already moved around £1 billion, and we are still in a monolith, essentially. The only change that we did at 30 engineers is that that monolith was separated into multiple deployments just because we didn't want to have, we wanted to separate the customer facing of the application from the back-end batch processing background jobs of the application. But it's still a monolith. So what happened between 2014 and 2017 is really the interesting part. Is, as you can see, Wise has grown to 200 engineers, and when you are having 200 engineers working on a product, you will eventually start to notice these problems that I mentioned about the monolith before. So this was the point where we actually started to invest into the questions like, okay, we are getting bigger. Obviously, the monolith doesn't scale with us, so what can we do? And again, I think there are many talks about microservices here, but what's really important is that we made some crucial decisions between this point to make sure that we can keep going fast. Because going to a microservice architecture is not like, okay, I'm just going to separate the code base and that's it, we're in a microservice architecture. You really need to draw up the domain boundaries, how are you going to try to shift things into an async processing way and whatnot. So in 2019, as we were getting more and more customers, we realized that in order to cope with the load that we were getting, it made sense to actually go fully cloud native to the cloud, and we actually went to AWS. At this point, we had 250 services with engineers, with 300 engineers, and as of right now, as you've seen on the previous slide, we are 700 and 750. So let's review the situation. It's like with monolith, you have long development cycles. With microservices, you probably don't, right? You have a small microservice, your team can work on it, it's much smaller than a monolith, you can go fast, great. Blast radius, same story, just because the code base is much slimmer than the original monolith, it's much less likely that there's going to be a problem. And if there is, you are very quickly to fix it. And the third one was complexity, if you recall. And the complexity is a bit interesting because you had this complexity with the code base, which was resolved, which was addressed, great. Now you can move fast, great. But you introduce this thing, like this microservice architecture, which is obviously a complexity. You traded the local complexity to global complexity. So what do? Well, you have multiple options, really. You can say that product engineers are going to be responsible for the infrastructure as well. But what we did at Wise was a bit different. What we have noticed is that, what we have realized is that we didn't want product teams to deal with infrastructure-related questions, so we came up with a platform team. And really, the platform team was a key aspect which allowed us to continue fast, because managing this microservice architecture is really a difficult job to do. You didn't need the product engineers to actually spend time on it. Instead, we spin up a platform team, and they were the ones who let the product engineers concentrate on the customer problems itself, which meant that we were able to go fast. So how did the platform team actually grow? So before 2019, we really didn't even have a platform team. We had an infra team, which was a team of jack of all trades. They were doing everything from DB management, CI/CD, physical infrastructure management, everything. And obviously, when we went to AWS, it made sense to actually invest a bit more, because in this way we can't really go any faster. So we created the platform engineering team. And as of today, we have around 90 platform engineers. Just to avoid any confusion, so we had infra engineers, infra team was one, and here we created a whole tribe around it. And I think what's important to point out at this slide is that as the engineering organization grew, so did this ratio, which is the ratio between platform engineers and product, or the total engineers, actually decreased. Because the truth of the matter is that as your architecture scales and getting more complex, you need to make sure that you're investing in your platform engineering as well, just to scale with everything and keep being fast. Cool. So we did the organization changes, we did the architectural changes. So are we fast now? Well, the answer is probably maybe, I don't know. One of the key aspects that you're going to encounter as you scale with the engineering organization and you try to adopting these techniques, is really there is one key element that will allow you to go fast at this scale, and that is safety. So what does safety mean? Well, safety means that just because you can go fast, you don't want to break the production environment like with every second release. Like that's obviously stupid. And at Wise, when we are regulated in multiple countries, we are financial services, obviously we need to make sure that everything which we are doing is safe and at the same time fast. So we came up with a couple of changes on our side, which allowed us to go fast and safe at the same time. And the first one was monitoring and observability. So in 2019, when the platform team was formed, and they were reading some of the postmortems that the product teams were creating, they realized that the time between detection and release was actually quite big, because the product team simply just didn't have the tools to really look into what was going on, like what went wrong in the systems. We increased the global complexity, but we didn't have the tooling available to help engineers actually cope with that new added complexity. So we set up a team which was responsible for creating this monitoring and observability problems that they should address. And really the key principles here was that, same with the platform engineering, is that we wanted to make the monitoring and observability aspect as transparent as possible, so product engineers didn't really need to know about like how, let's say, monitoring and alerting and this observability works. But the only thing that they needed to know is how to actually use it. So that's about this don't make me think. And how do you make sure that people don't need to think and everything works the way that you should, as it should, is that you do observability by default. So at Wise, when you create a new service, essentially it's going to come up with an observability library, which by default emits a bunch of data to our central infrastructure about our service states and whatnot. And it's really easy to define additional business-related metrics. So again, you don't really need to need to think, and it's really easy to provide observability. And I figured that it would be a good idea to show you like an example what I actually mean. So this is our deployment tool, which we're using whenever we want to deploy something to production. And what do we see here? So this is for one service. Obviously here are the pods that are running in production. And when you want to release something, it's basically a click of a button. What you're going to do is get the version number, and here, play, don't make me think, and the deployment will start, and you don't need to do anything else. Just because it's this simple, which allows people and engineers within Wise to go this fast. Like, this is not a complicated process at all. All right, so you did your release. What now? Well, immediately you can see some golden signals, which are some metrics about the service, which you can actually customize here. But probably you will need a bit more details into your service. And this is really what these like icons came into play. These will take you to our observability stack by default, not by default. So this will take you to the observability stack. For error monitoring, by the way, we are using Rollbar. For dashboards, we are using Grafana. For logs, it's Kibana. And I think, yes, and the metric is Prometheus, and the alerting as well. And that's it. Everything is in one place. As a product engineer, you really don't need to bookmark like different websites, anything else. Everything is at your hand. So the last thing that I want to talk about is, again, comes into this notion of safety. Again, in order to go fast, you need to make sure that your release is as safe as possible. How can you ensure that? Well, you ensure it by actually introducing continuous integration, which verifies your change in every step of the way. So how does a typical feature implementation looks at Wise? So basically, as an engineer, you will create a new branch, and it's very easy to run the test both in local with Docker, or if you have a complex change which you want to test in a Wise-like environment, you can spin up a custom environment, again, with like a single click of a button, which will create a Wise-like copy of an environment when you're free to release your services and you're free to experiment. So let's say you're done with the feature, now what? Well, now you're going to create a pull request, and we have multiple change management policies here to make sure that as a financial company, we are doing the checks that we need to do so that you don't release something out to the production. Again, the really important here is all these guardrails or like guard steps that make sure that we verify your package at every step of the way. And once you have the review, you did all the checks, then it's time to go to production, the artifact is promoted, and you're ready to go to prod. And how do you go to prod? Well, you have already seen the screenshot, and this is really like CI/CD, so you have continuous delivery here, and continuous delivery essentially in this context means that you want to provide a way to push changes to production in a safe, sustainable, and a quick way. And really, this is what we are trying to do with the dashboard. And again, even if you did all the changes, even if you wrote all the tests, like things can still go wrong, right? Like we're operating in a microservice architecture, things will just go wrong because you don't know everything, and that's fine. And this is why we are providing these safety features. One is a canary deployment. With a single click of a button, you're able to create a service with a new version, and you're able to roll out a small percentage of the new traffic, or not the new, like the existing traffic to this new service. And if there's something wrong, like you're just going to delete it, and that's it. Like the blast radius is this small, and you're easy to experiment and release new things. And for some reason, if you're rolling out some complicated feature which spans across multiple services, obviously you cannot release services at the same time and hope for the best. That's like not good. Instead, what you do is release your feature, or actually deploy your feature, but you turn it off. So even though you have a new, let's say, code in production that is not getting actually executed. And then we have this central service which is working with feature flags, and this allows you to do something like, hey, enable this new functionality for like 1% of customers, or 10, or 25. And it's really easy to incrementally scale and learn and see what the customer behavior is. Is everything working as expected, as we wanted? And when you have, again, ways like this to ensure safety, you are okay to go fast, because you know if something goes wrong, like you can deal with it. And most likely it's not going to go wrong because you have CI there and testing. So that would be it. Just to recap, going fast and going safe is probably a right investment for everybody to do. Why? Because you have customer impact sooner, you can learn about the customers also sooner, and you can reduce the risk. And some of the changes that you might want to try out is organizational changes, architectural changes, and some practice changes. So I know that this is after lunch, and there might be people who now feel a bit bad that they zoned out right in the middle. To you, I say don't, because everything that I've said and more can be found on our engineering blog. So I encourage everybody to check out. But other than that, thank you very much, and wish you a great remaining day.
Thank you, Attila. As a non-tech person, I can say I followed your talk from start to finish. I loved it. Thank you so much. For all the non-tech people here, which there may not be many of, but let's take a look at some questions. So there's 4 questions here. I'd like you to choose the one that you have time for.
Is there a difference between, like, is Hydro a person?
These are the screen names, let's say.
Okay.
Yeah.
All right, so we have yes. All right, let's start with from the top. So we have a question about. Can I read it aloud?
Sure.
Yeah. Okay. Would you say that with the platform team in place, software engineers are not forced to do DevOps, unlike in many other companies? So exactly. That's what I was trying to basically communicate when I was showing you the slide about the platform team. Again, there are 2 schools of thoughts here. One is that engineers should do everything, and this is what I mean. I guess the author means forced to do DevOps, is that if you're a product team, you're writing business code which will directly impact the customers, and at the same time you're also, managing the infrastructure, right? And this is not what we are doing. At Wise, what we are doing is a bit different. Again, we have a central platform team. They are the ones who are responsible for this central infrastructure. And as a product engineer, you're empowered to just deal with the customer problems. And why does this make sense, especially for us? Is because when you have product engineers dealing with infrastructure, what happens is that a lot of the knowledge is actually duplicated, right? Like let's say I'm in the US team. Okay, so now I'm learning about AWS and Docker and Kubernetes, and that is very useful. But the problem is, like, Zoli, who is also leading the Europe team, he's also learning about AWS and Kubernetes and Docker. So there's this duplicated knowledge that we have here, which is really good. But the problem is that this takes up mental capacity. You're not fully committed to the customer problems. So what we have chose is that product teams only deal with the customer problems, and we let the platform team deal with the infrastructure-related questions.
Okay, we have time for 2 more.
All right. Okay, everything is uploaded at the same time. So are you doing manual testing in case of any of your Are you doing manual testing in case of any of your services? Is quick releasing possible, even if some manual testing is necessary? I mean, yes. So by default, we try to validate everything by test, right? Like we write the proper integration, unit test, contract, whatever you want to write. We do that, and then we go to production. And then, because when we have all these guards in place, and we are following these practices, like you can be sure that like you have a high percentage of chance that you will actually release something that is correct. And even if you don't, you can quickly go back. But obviously, I'm acknowledging that sometimes things are just not black and white. Black and white. Sometimes you actually need to. Maybe you're doing a complex change, and you actually want to do manual testing because you want to see how the UI looks and whether this backend process and like 2 different services actually trigger. In that case, yes, we are doing manual testing, and there are multiple ways that you can do it. One I already shared, it's a feature flag. Maybe you're turning this feature only on yourself, see how the production system operates. Or if you want to play a bit safer, you can spin up, again, with a click of a button, an exact copy of Wise's infrastructure, only for you. You deploy your services there and see how it behaves. So really, we have all these options to do manual testing. It's not, so everybody's free to do manual testing if they do, but usually, we try to avoid it.
And the last question.
All right, so, okay, so let's start with, how are extensive refactoring supposed to be released in an iterative fashion? Well, I mean, it's a difficult question to cover. It really depends what kind of refactorings are you doing. So, I don't really have a good answer here. It really depends on case by case. I'm pretty sure refactorings can be still split it up, and you can release those changes in pieces. So you reduce the blast radius and the change size.
All right, wonderful. I'd like to present you with a gift.
Oh, cool! An iPad.
Yeah.
No.
This is a custom Budapest notebook, and inside, an artist rendering of your face.
Oh my God, that's very cool.
I present this to you. One big round of applause, please, for Attila.
Thank you.